Hey everybody, welcome to our last Robots to the Rescue webinar tonight. This is going to be a kind of more open format. We do have some slides to run through, but while you're thinking of questions, you can go to pollev.com/firstptc123 and start adding your questions, and we'll get to them after we've given a quick rundown and reminder. So feel free to keep asking your questions online at this pollev.com, and let's get started. So tonight, I'm Domenico Damari. I'm an applications engineer here at PTC. I'm joined by my associates, Mackenzie, who's also an applications engineer, and Mark Celli, who is an academic experience senior manager. He'll be in the background fielding your questions and helping with some logistics. So it's pretty straightforward tonight. We have a couple quick reminders and a little bit of information we want to give you, and then we're going to open it up to just a Q&A session where you can ask us questions about the competition, submission, any of those concerns that you might have that we can hopefully get answered for you. Of course, the challenge is to design a robot that solves a current world problem. Hopefully you guys are almost done with that. If you have any questions or concerns, you can always check out our submission webinar, which is now up on our YouTube page. We encourage you to check out our rubric that the judges will be using, our example submission, and all of this is up to date on our website, where you can also find the link to submit. For any clarifications, please feel free to reach out to us at first@ptc.com. Covering some resources to help you if you're having some trouble using Onshape. There's some great learning pathways on learn.onshape.com. For example, there's the introduction to CAD if you haven't really used CAD too often. And if you are moving from a different program, we recommend you take the Onshape fundamentals to learn more about how to use Onshape. There are also some parts libraries out there to make your life easier. There's the FRC one from MKCAD, and there's the FTC one from Team 2901. So the submission deadline is coming up this Friday at 11:59. We can't wait to have all of your documents and see what you guys have done. So we've basically gone over all of our webinars. Tonight's the last one, the Robots to the Rescue Office Hour. And you can look forward to an email from us regarding what type of award ceremony that we are going to be hosting. You can also check out our social media pages to learn more about that soon. So again, please put your questions into the pollev.com/firstptc123 if you have any. Before we get there, we want to address a question we've gotten about large assemblies, and people have been having maybe a few issues sometimes with Onshape not working how they might expect, or just having general issues making some really high level large assemblies. So we want to share some best practices when it comes to making these top level assemblies. First, regarding documents, generally documents should have less than 40 tabs in them. If you start having issues, you think, where things are acting weird, or it's taking a really long time to load, and just general usability issues, what you might want to do is separate your top level assembly into separate documents. That can really speed up the process and make everything much more usable for you as you design things. This is also something which will help the judges when they look through your submissions, if they can easily explore the kinematics of what you've designed. And another thing that helps with this is using versions. So when you import an assembly or a part into your top level assembly, you want to try to use a versioned part or a versioned assembly when you import. This improves performance and makes it easier for you to control if you don't want every single part to be updated. Regarding mates, when you make an assembly, you really have to start by thinking about what type of relationships you need between parts. And when you do this, you want to use as few mates as possible, because in an assembly, the largest thing being computed is these degrees of freedoms between parts that mates define. So you want to kind of take a step back and think about what's the least number of mates I can use to make these relationships between parts. In general, you might also want to avoid using lots and lots of revolute mates. Sometimes this is an easy way to over-constrain or over-define an assembly. So you might want to try replacing some of those revolute mates with cylindrical if you're having lots of issues. And another really great tip is if you have a bunch of parts that don't move relative to another, and you might think you should use a fixed mate, a better way to do this might actually be to group them together. A group basically fixes all of the parts together into that aren't moving relative to another. So really make sure to take advantage of that. A group is a lot easier to solve than a bunch of fixed mates for Onshape. And another best practice is you want to avoid interferences and collisions in regards to motion. Whenever you have parts in an assembly that end up overlapping or interfering, this leads to some problems within any sort of CAD package. Not only does it not make sense to a judge when they're looking at your assembly, it also doesn't really make sense to the background solvers in these packages. So now we can kind of get to any of your questions.
And I think, well, people are still submitting their questions, just to kind of go back and talk a little bit about the assemblies. I'll share my experience. I'm a longtime Creo user. I was, very much an expert in Creo. Now, when I switched to Onshape, there was a lot of things that kind of tripped me up, like part studios, for example, in Onshape. Like I just couldn't get that concept at first because I was familiar with Creo, which doesn't have that same concept. But as I kind of got to know it, I figured it out, and then obviously I got a lot faster. I think assemblies is one of those things as well, where deciding how big of a project should a document encompass, right? How many tabs should have, and all those kinds of things. At first, it very much tripped me up, but I think if you follow some of those simple rules, it really does get to be really fast and a lot easier. So.
Yeah, and real quick, I'd also like to highlight these resources. If you go, when we post this, you can go to these links. There's the 10 essential Onshape tips, and these are 10 essential kind of high-level tips just to along the same lines of how many parts should be in a part studio. Some tips like this that can help you improve your assemblies and your documents. And then you can also check out the best practices for managing data in an Onshape document. This kind of takes these tips and then goes more in detail of the best practices for using these tips and really dives into how to use them.
Right, so our first question is, what is the best way to do wires?
Yeah, so let's see if I can actually show this to you real quick. I've got a part studio here that's kind of empty, but it might be useful here. So you can actually add in the custom features, you can find a feature script called wiring, and it's super convenient. And so what you need to do with this is you can define some different parameters about the diameter of your wire and the number of wires. If you say had like a bundle of a bunch of wires, you can also define your own custom profile for those wires. I don't believe I actually have any points right now in this, so I'll have to do that. When you're defining and making a wire, you do have to have a sketch with some points in it. because you're defining from point to point, basically. So we should have those points in there. This might not be happy, but there you go. So this kind of gives you a quick example of how you can make a wire. And this is only a feature that you can use in a part studio. So you'll have to use it from parts that are related in a part studio, or know the locations of where the other point is that you want the wire to end.
I just posted a link to a further description and a whole blog post about specifically, where to get this feature and how to use it. So that's in the GoToWebinar chat.
Yeah, and another great thing you can do with wiring is if you're having wiring from moving parts in an assembly, in a top-level assembly, that's probably not going to work too well. So what you might want to do is create a configuration where you have the wire features, the wire parts suppressed or hidden.
Then our next question is, are the contents inside folders counted in that 40 tab restriction?
That's a very good question. So in general, think about the 40 tabs restriction as anything that the CAD solver is going to have to figure out. So for example, 40 part studios, but 40 PDFs wouldn't, have an impact on what is being solved.
I'd also say that that's definitely more. I'd also say that that's definitely more of a recommendation for performance rather than a restriction. If you were to submit something that has more than 40 tabs, that's not going to impact your score at all. It's just going to be how you might see the performance when you're using Onshape.
And that 40 number is the general guidance provided from Onshape. If you had 100 parts that were all really simple, then there probably would be almost no problem, and you could probably have maybe hundreds of those. So it really kind of depends on the situation, but 40 is a good rule of thumb to try and stick to as best you can.
The next question is, when splitting a model into separate documents, how do we make sure the judges know what we've done versus what is coming from a library?
Yeah, that's a great question. So when you split your model into separate documents, we can still see in that top level document every single part and every single assembly that goes into it. And we like making sure your document is public when you submit it to us. If you do have separate documents, please make sure those other documents are public as well. And then we can see the history in those parts and see what you have custom designed.
All right, so then the next question is, how do we show animations of parts which we cannot add as CAD files, but I've explained them thoroughly in the documentation, such as inflatable items?
Yeah, you definitely don't have to figure out how to make an inflatable item in CAD. Not a lot of people have, and everybody here recognizes and doesn't expect you to design an elastic balloon in CAD right now. So don't worry about that. As long as you explain the idea well, that's great. And what you can also do is in your assembly, have a configuration. One configuration maybe where that inflatable or expandable item is collapsed, and another configuration where it's fully inflated.
Then what is the best way to move an assembly and associated part studios between docs? So if you need to consolidate your design into one document for submission.
Yeah, so first of all, you don't have to consolidate your design into one document for submission, especially if it's a really large assembly that you're having performance issues. Don't feel obligated to put everything into one document. Instead, just make sure you have a top level document with your top level design and your documentation and your problem definition in one document. And then we'll be able to see the rest of your parts through that. If you do need to move your associated parts between documents, there's a few ways to do that. And let's see if I don't think I can actually show you right now, but on the Learning Center, there are some technical articles on how to do that, and it's pretty straightforward.
I just posted in the chat. There's a whole nice section. We called this out when we talked about, if you have a document that has a lot of tabs, it might make sense to break it apart. I posted a pretty comprehensive document that talks in further depth about why you would want to do that, what the best practices are, but also, how to move things between one document, right? If you have an assembly, you want to move it to another document. It's actually pretty easy. There, you just kind of right click and you say move to document. So there's a lot of strategies for it. And it gets into the more kind of comprehensive side of it, which is if your document is versioned and you're moving things around between version documents, how does all of that work? So it really does kind of go through that. So I'd recommend just checking out the link I just shared in the chat.
Great. So the next question is, what is a configuration exactly?
Yeah, so a configuration is a great tool within Onshape where you have the ability to change pretty much any feature about your part or about your assembly through a easy to use interface. Let's see if I can show it. There's also a lot of great resources at learn.onshape.com about configurations and how to use them and how powerful they are. So let's see if I can add one quickly. So this is obviously some sort of bar with two holes in it, not too complicated. So on the right here, you have this tab that's for configurations. So you can add a configuration to design, to drive different variables within your assembly or part studio, whichever it is you're using. So you can kind of add one of these. And then all you have to do is choose what it is that you're configuring. So let's see, what do we want to, what's a good thing to configure here? See, maybe you're worried about the thickness of this bar. So you can set it up as a configuration. So you have a default state, which is the state you designed it as. And then if I should be able to name, say, call it maybe thinner. I can input a different number into there that might break some other things in this assembly because it wasn't really designed for this. But now up here at the top of our feature list, you have the options of the different configurations that you've made. So in this case, thinner just makes the bar thinner to 0.25 inches, or you can have it as your default as 0.5 inches. And there's a lot of different things you can do in here. You don't have to just have this binary change of dimension. You can use it as an input where up in the configuration, you might actually type in 0.75 inches and it would make the bar 0.75 inches. You can also add different configurations of features where you might have maybe these holes suppressed so that they don't actually have any holes in the bar. So that's what a configuration can do. You can learn more at learn.onshape.com, and I recommend you check it out because it's a really powerful feature of Onshape that other systems don't have.
Yeah, I've added some documentation to the chat as well. It is really one of the most powerful parts of Onshape. And you know, just to add some color to what Dom said, at a high level, you know, very often you design something that has different versions of itself, right? You can think of like a C channel part that you might use from, you know, Tetrix, for example. They come in, you know, 10 millimeters, 30 millimeters, like they come in all these different sizes, but it's really the same design, just in a different length. Configurations is one thing that's really useful for that, as well as your robot may have a starting configuration, and then it may have a configuration for what it looks like kind of as the match starts and spins up. So it's really useful for all kind of manner of things in kind of the literal sense of the word. So people get really creative with configurations too and use it for things we never expected it for. So posted the documentation in the chat there.
And also, if you've been using that library from Team 2901 or the MKCAD parts library, a lot of those parts have configurations. And so in the 2901 library, they have some configurations for channels that you can be using. So then the next question is, if we are creating our own wires, is it necessary to create the connectors example, or for example, Anderson power pole connectors and servo motor connectors?
Yeah, if you have more time, definitely making your robot as accurate to real life as you can is part of the competition. We'd much rather see you concentrating on making a robot that is functional and, you know, has kinematics and animatable mates in assemblies and really coming up with a great problem definition. But if you have extra time, go for it. Make some of those more intricate connectors.
Yeah, I think it falls into this kind of level of cosmetic detail, right? If you were to add the actual connectors, like it looks better, but it doesn't necessarily change your design, right? So as Dom said, if you have an infinite amount of time on your hands, that's great. But I think otherwise, like a double check on spelling in your problem document probably would be better served than necessarily, you know, spending time on every tiny detail on the cosmetic side of your robot.
And I'd also say definitely be thinking about this as a preparation for next season. So what is your team going to want to do when they're making that robot during the actual first competition season? Would you want to have those connectors to have them as part of your bill of materials, or do you not think that you'd want to do that? Because if you do think you'd use them, that's definitely a good chance to practice and get learning how to do that now. So my next question, in many instances, motors and sensors don't have any wiring ports. So how do we attach the wires to them?
Yeah, so that might depend on how you're going to make those wires. If you're using the wiring feature script, then you have to wire from point to point. So you could just make a sketch or on wherever that wiring needs to go and add a point to that. And then when you use the wiring feature script, you just click on the 2 points and the wire will go between them.
Another question about wires is, would wires be considered a cosmetic feature in this challenge?
I'll jump in. I think they're more cosmetic than the structural part of your robot, but they're less cosmetic than like the threads on a bolt, right? Like, you know, if you had threads on a bolt, like you're not doing that necessarily to enhance the definition of the model. whereas wires usually aren't structural, but it's still really important to know what wires are going where, especially if you have a, an arm on your robot that goes really far out. You need to make sure the wire is included in the design. So I think it depends. Like every tiny wire, probably not, but larger bundles of wires that have to run in your robot are pretty important to make sure that you know where they're going to be and how they affect weight and various aspects of it. So it's somewhere in between. It really depends on your how you view the situation, right? And kind of the intricacies of your use case.
And our next question is, our team is extremely new to Onshape, so how much of the robot do you actually have to build in Onshape?
Yeah, so the rules and guidelines are up there on our webpage, but we want to make sure that you have at least one assembly, that top level assembly that is an Onshape assembly, and then we want you to have designed at least one part in a part studio in Onshape.
Great. That's all the questions that we have in the queue right now. So if anyone else has any questions, please be going to this pollev.com/firstptc123 to be inputting any of those questions you may have. I will say we're definitely very excited to be seeing all your submissions. If you have any questions too about the submission itself and not just about using Onshape, we're definitely happy to answer any of that. We got another question in. Oops. So how do judges judge a CAD robot? Do they move every part to check mates, or do they focus more on the robot itself? And so that's actually a great question. So we're going to have actually a couple different types of judging going on. We're going to have some people that are going to be looking at your submission document, and then we're going to be having some of the experts at Onshape looking to make sure that people are following those best practices and that things are moving as would be expected. So it's a little bit of both. We're definitely going to be focusing on the robot, and then as well looking at the mates and looking at how the robot was CAD'd in Onshape.
Yeah, I think one of the most important things to note is that it's a little bit of everything, right? The document's really important, right? The document helps us to guide in terms of what is the problem? Is it a really good problem that you're solving? And I think the CAD techniques is really important. This is obviously an Onshape competition, so we want to make sure that you're doing things best practices and that you're really kind of putting in effort to the design aspect of it. And then just simply like how innovative is the robot that's solving the problem, and how interesting of a design is that. I would definitely refer to the judging rubric to show kind of the emphasis that we're placing on each of those areas, because the judging rubric really is how logistically as judges, judges are going to be assigned different categories to go through and review the robots on, and then we'll have stages of the judging where all aspects of the robot are taken into consideration to kind of evaluate the score on the whole thing. So that rubric really does show how we're going to look at things and what the emphasis on the different areas are. So.
And another question is, who created Onshape?
I'll take this one. So some of you, there's this guy, John Herstick. I would totally recommend looking up his story. It's super interesting. So John Herstick went to MIT. He, is, way back in the day, he was on the blackjack team over at MIT. If you've ever seen the movie 21, it's kind of actually somewhat about him. He started a company called SolidWorks, actually. If you can believe it, he was the founder of SolidWorks as well. He started that company and he ran it for quite some time. It was acquired by Dassault. And he continued, with that company for another like 15 years. I think it was around 2008 or 2010. He left with a lot of the other founders of SolidWorks, and they started Onshape. Actually, a lot of people who work on Onshape are SolidWorks people, former SolidWorks people, obviously. So yeah, John Hirschtick is the creator of Onshape, along with John McNulty, he's a co-founder of Onshape as well as SolidWorks. So really interesting story that these few people were able to disrupt the CAD market, as we like to say, not once, but twice with SolidWorks and with Onshape. So really interesting story. Definitely look up John Hirschtick and John McNulty.
Thanks. So in this one, there's two parts to this question. So someone asked, if we have made our own speakers, do we need to connect them by wires to the expansion hub, or do we connect them by an aux cable to the phone? And then if we've made our own speakers as a placeholder for another existing speaker.
Go ahead, Mikan.
So this seems like a more detailed question about how you would connect them on the robot itself. And one thing I will note is I don't think you could really tell which type of wires you would be connecting in Onshape. I don't know if Mark had a different answer that you were going to give there.
No, I guess if this question is logistically, like how would this work in real life? I don't know if we directly have the answer here, but if the question is like, how should this be represented in Onshape? I would say I don't have the context to make a judgment call on that. Like if you think it's really important that those things are shown and labeled appropriately, and that's kind of integral to the design and important to a well-detailed model as kind of we're asking for here, then you should include it. But if you think that's a supplemental detail that, isn't important, then I would say you shouldn't. And if you have, if you really want a detailed answer, if you think that's really conflicting and it could go either way, I think what we would probably need to see some screenshots and maybe see your model to kind of give you further guidance on that. So if you take a screenshot of like where those two parts are in relation to each other and send it first at PTC, we can help there. But I'd say think about it in terms of, is this an essential part of documenting the detail of our actual 3D model?
Next question, what things should be prioritized in CAD? For example, doing the wires, bolts, drawing the parts to get the most amount of points if we're running short on time.
I'd definitely say take a look at the grading rubric that the judges will be using. You can also check out our webinar from last week that's up on YouTube on our PTC YouTube page now to give a little bit of context about how things are being judged. But in general, you want to make sure you're adding things to your design that are going to get you the most points according to the rubric.
Yeah, and I think definitely the focus would be on. Oh, sorry. You can go ahead.
I was going to say, if you are short on time, I would say wires and bolts are probably not that important in the grand scheme of things, right? We want to be able to kind of quickly glance at your model and understand like what it does, right? So big structural components are definitely the most important pieces there. And then, if like definitely look at the rubric because, really the completeness and complexity of design is one section, right? If you're demonstrating, feasibility and utilization of first components and ability to solve the problem, those are, the three other major categories within the design section. So look at that closely, and it's not, providing as much detail as possible is one aspect of it. That's completeness. But if that is the time constraining piece, right, adding bullets is going to take too much time. You may want to look at those other three areas to really kind of maximize there.
Yeah, I'd say probably the quickest thing to finish would be making sure that you got all the components that first typically requires of you. So if you need to figure out, I don't know, what you can get you the most points in the least amount of work with less time, I'd say definitely the fastest thing is going to be getting those things like the battery pack or whatever control system you need based on your program. So I'd say those are the things that are going to be the fastest and easiest to do, but definitely getting a complete model is going to be the top priority. And then what are some other tips we have for when submitting the robot?
I would say reference that webinar. We did a whole kind of 1 hour session on what we're looking at and kind of tips for it. At a surface level, the highest level, most important thing is when we open the document, it'd be great if it kind of guided us through. It was simple and easy to follow. We will be looking at the grading rubric in order, obviously, to grade yours. So if it's easy for us to open the grading rubric, open your model, and go through it, like that really is helpful for us. That's not necessarily a tip to get more points, but it is helpful in the process. So at the top level of the document that you're submitting, having your PDF clearly visible, maybe being the first part, the first tab that's visible in Onshape, and then having your top level assembly being the second tab, right? That could really help us in terms of making sure that we see the right thing, right? There is a chance that somebody submits a model and it's so much of a mess that we can't find the top level assembly. So that one's really easy to avoid just by making a nice clean structure within Onshape. So that's probably my biggest tips, but for more, go to the PTC YouTube channel. I'll post it in chat here in a second. We did do a section specifically on more of the information on what you should do for submitting your robot.
I'd say also something, I come from the FRC world with chairmans. I've helped my team with chairmans every year. And the big thing I always have my teams do is go back and read the questions and read the guidelines and make sure you've kind of got everything there. So I would say definitely go through both the rubric and our submission page and then the example document as almost a checklist. Just make sure that you kind of answered everything and that you have everything there, especially in your PDF submission. We worked pretty long to get some questions that we think would be helpful in guiding and what you could put in your PDF document. So definitely the more you can go through and kind of check, did I answer that? Do we have that included? This is a last minute check before you submit. And then once you submit, we are going to be making a copy of your document. So whatever you do after that won't be included. So I would say just remember your submission is final. And then, so I think we answered the first part of this question earlier in the webinar, which was how do you create and work with wires in Onshape? That was using the feature script that Dom had shown earlier. So if whoever asked this question didn't see that part, we will be posting this recording. So you can go back and look there. And then the second half of the question is, can the wires be moved and kept to constraints?
Yes and no in some ways. So when you make a wire, you have to make it as a part in a part studio. So you can try to make it yourself by creating a wire path and then creating a extrude to go along that path. You can also use a feature script wiring, or there are other feature scripts you can use as well that create wires. But what it does is it creates a solid part. So the wire itself isn't going to bend as you move things in an assembly. It can be kept to constraints. You can import the wire as a part into an assembly and use mates to put it where you want. But don't think of it as like you have a wire going from the motor to the end of an arm that's moving, your wire is not going to follow that arm as you move it around. This is a little bit why I mentioned configurations. You might want to have a configuration of your assembly that has wires, in a sort of default state, or at both an extended state and a unextended state. That would be one way to show that you've thought about the wiring paths or something like that. But it's not something that bends like you would a real wire would.
Yeah, and just to go off of what Dom had shown earlier, the feature script for wiring is really, really simple. It's essentially you define a series of points and then it draws a line through those points. So if you, like Dom said, it won't be flexible in assembly. It won't change when you're actually assembling together. But if you have a part studio and you define a series of points that are like offset from a surface or placed in location relative to other parts, as those points move because the relative geometry moves, the feature script would then regenerate as the new shape essentially, and it would draw a line through the new shape of those points. So it's parametric in that regard, but it is not flexible or movable and necessarily anyway. So.
And the next question is, can we use more than 3 pages if it includes drawings, or does the 3 pages include drawings?
We discussed this a little bit on our last webinar, so if you want to check that out on our YouTube page, that would be great. But the short rundown is, we as judges will guarantee we'll read 3 whole pages of text. So that would be your problem definition. Anything else you might want to include in that problem definition and how your robot solves it. If you have drawings that are separate in your assembly, we'll definitely take a look at them, and we'll definitely consider that as part of not necessarily that 3-page document. That's the 3-page document really just pertains to your problem definition.
Yeah, and I think if you were to include a drawing in your description, it would be good if it wasn't necessarily like an engineer's drawing. I mean, it certainly could be, but it's more annotated to provide context as to, this is the gripper that grabs this thing, right? And it's tied to the problem description. If you do have engineering diagrams or manufacturing diagrams, drawings, if you have engineering or manufacturing drawings, keeping those in the Onshape document, as they're essentially their native form, is probably the best way to go. So.
The next question is, how do we show that we used first parts? For example, providing a list of first parts. And I can take that question. So I'm essentially working with some of the judges, similar to when you go to a competition. You know how the inspectors will have an inspection sheet that they go through. So I'm creating a list of those components that they would be looking for and finding. So I know the FRC side better personally, so the PDP and the battery and those things that they'd be looking for, the radio, Robo-Rio. So we can have those that are the required components for the judges to be looking for. So we'll have that for the judges, similar to what you have at a competition. And the next question is about how we'll judge the documents. Again, I would definitely refer back to that previous webinar we did, because we really went into each line of the judging rubric and what we were looking for at that for each section. And so we'll really be using that rubric. That is absolutely what we're handing to the judges to say, this is what you should be looking for on each submission. So I would recommend looking at the judging rubric in last week's webinar to get a deeper dive into that judging rubric. And then the next question is, what does it mean by drawings for all design parts and drawings in general are helpful in the robot description section?
I believe this is referring to the example document, if I'm remembering clearly, Mackenzie.
I think so.
I'll see if I can pull that up here. In the robot description. So drawings for all design parts. If you could, you know, drop another question in or something like that, that might be helpful for context. Drawings for all design parts and drawings in general. I mean, I think really what it's referring to is just providing definition to the model, especially if you make, you know, your design hinges around this really intricate custom part that you've developed. A drawing for that obviously is important to understand, well, how does this design that you came up with accomplish the objective that you're setting out to do with it, right? You know, oftentimes the most innovative designs don't really look like anything that we're familiar with, right? So if you design something custom, it'd be interesting to know why did you do that? Why did you spend the time on that? And what is the purpose? I'm guessing that's where it's been referred, but I actually can't find that in the document now that I'm looking at it. So if you can provide some additional context, that'd be helpful.
Yeah, in general, we'll be looking for drawings that show us how you've thought about actually, say, machining these parts. There is a section of the rubric that's feasibility, and to get all 5 points, there's criteria for manufacturing documentation. That's what drawings would be part of, this manufacturing documentation, because you can design all sorts of things in CAD that aren't necessarily creatable in the real world. So we want to see that you've thought about how you would actually manufacture this robot if you had to.
Yeah, the last video for the webinar, it wasn't online. We had some issues uploading it, but it is online now. So I just posted the link in chat. I'll post it again, but that should be online now. And let me know if you guys are having issues accessing it at all.
So next is, how do we show we worked with another team? Like we helped another team with their robot chassis. So how do we show that? In the submission form, you should be able to answer what you did. That'll be part of the bonus point section on the submission form. The next question is, how long will judges spend on each project?
It's a great question. I think we tried to calculate this because we have over 450 teams who have entered the competition. So we were trying to calculate, if we spend this much time on each project, how long does it take? I think in general, I think we were just about an hour at least for each project. So you can expect, I think, that at least that much in total. Like we said, we're going to have kind of different work streams where we look at the documentation, and then we're going to look at the robot, and then we're going to evaluate it for things like using the correct parts and all of that. So we have these kind of different work streams, but in total, that's how long you can expect. And if we've got a couple close, like at the very top, everybody in this group got all 5s on everything, and we really need to evaluate them, we might spend a lot longer just to kind of make the decision there. But we want to make sure that we definitely give time and attention to each robot. So I would say expect an hour of us looking at it from those different stages.
Another question is, what are Onshape parts and what is their purpose?
I would refer you that question. It's a great question. I think there's a lot of things that will kind of flow from it. So what I would recommend is the CAD fundamentals pathway on the Onshape Learning Center. I'll provide a link to that in a second. That walks through parts and assemblies and how all of those work together to actually create a full design. So I'll provide that link in just one moment.
And that being said, I definitely recommend looking at the chat. There have been a few different links posted throughout as some of these questions have been answered and these resources have come up. So if you go into the chat and click those links and bookmark them for later or save them some other way, there have been a lot of helpful resources shared tonight. The next question is, what kind of people are the judges? Are they engineers, CAD people, etc.?
Yeah, we've got a pretty good mix. So we have people who are business, who might be reviewing the project description. We have people who are, engineers, plenty of engineers, mechanical, software. We have people who are on the Onshape team that are actually, in development and work on this every day. We have people from technical services at Onshape. So technical services, basically, if a company needs consulting on how to use Onshape, they are the ones who help. So they are considered like some of the best at Onshape. They'll be helping to look at the best practices. So there's a mix, and we've tried to make it so that the different volunteers we have that are looking at the submissions are looking at kind of the areas that they're experts in. So it does kind of span the gambit in terms of business, marketing, software engineering, mechanical engineering, CAD, pure CAD expertise. And the crew that will actually decide on the final winners, the first, second, third, and the finalists, they are an interdisciplinary crew as well, of all of those different disciplines.
One of the really cool things I'd also like to point out with this contest, I know there are some people that have come from FIRST, and there's a lot of people who hadn't really heard much about FIRST and hadn't known as much about the program. And so letting them see all the really cool things that you guys are doing and designing is a great way that you guys are all working to spread that mission of sharing FIRST, similar to what you're doing when you're trying to submit for some of those awards. So you're actually working to reach a lot of our company to help them learn more about what this program is. So that's something that I find really cool about it too.
Yeah, I mean the finalists and the top tier contenders, I can absolutely guarantee that the CEO of PTC as well as the founders of Onshape will look at your models, like, for sure, if not every single submission. I mean, what we'll have at the end is a really cool list of all these public links that we can share within the company, and we're absolutely going to do that. So keep that in mind, is that the CEO of PTC and the founder of Onshape are probably going to look at the cool stuff that you guys submit. So that's pretty exciting.
And then another question is, can we submit a 3D animation video of our robot?
Absolutely. That sounds quite cool. And I think it helps to give some context as to the robot as well, right? In terms of how it would work in action. So it's by no means required, but it is an interesting thing that would be cool to see.
The next one is the Most Unique Design Award following the rubric, or is it a judged award or judges award? So I'd say definitely following the rubric. all submissions are going to be graded following the rubric, but then it'd also be something where someone got a lot of points and then they also were judged to have something unique and interesting about them. So I'd say it's a little bit of both.
Yeah, and there's those 10 additional judges awards. Those are going to be largely judge awards. So those 10 categories will kind of be determined, and might be things closely related to the competition, certain aspects of the design that were top, or could be somewhat unrelated. So even if your robot is not like you consider it to be elite and super amazing, there's certainly these other categories that you'll definitely be considered for. So everybody should submit, even if you think you won't win, you certainly might win one of these other categories in the smaller prize pool of the 10 judges awards.
Yeah, so I think that kind of answered this question as well, but what are the 10 awards not listed in the rules and requirements? Again, those are kind of to be determined as we look at the submissions. If there's anything really neat and interesting we feel like we want to call out during our award ceremony, those will be those awards that are given later on. So the next, how important is software as a consideration in judging? I don't see anything about software or programming in the rubric.
I would say it is not an essential part, especially of the rubric. It's important so far as to say that some software would exist that would make your robot theoretically feasible, right? But I think you all are aware of that. But by no means do you have to write software. Sorry, I might have created this a little bit of confusion when I mentioned that we will have software engineers contributing to this. I mentioned, so those are software engineers that work on Onshape. So therefore they are pretty deep experts in Onshape. So they'll be judging from the Onshape perspective, not from looking at your submission's software component, because we do not expect a lot of teams to have the software as an included part of their design.
The next question is, are FTC and FRC teams judged separately, or are they both competing against each other since they have different hardware limitations and size constraints?
Yeah, FRC and FTC teams are going to be judged together. They're going to be competing against each other. The rubric applies equally to both of them, although of course, judges will take into account as they look at things, the different requirements and the different size constraints as to what the robot does and what the problem that the robot is solving.
The question about, do we get college credits for winning or participation? No credits are given for it for college, but do keep in mind that if you win, then you can earn grants for your team for next season. So that's definitely a helpful bonus in getting started for your next season.
I'd love to give you guys college credit if there was a way to do it, but unfortunately we don't have a way.
And then it looks like we got a potential clarification for going back to this question about what it means by drawings for all design parts and drawings in general are helpful. This is saying it might have been referring to the rule clarification and the submissions requirements of the rules and requirements. So the rule clarification was for custom parts, we'd like to see drawings that illustrate the manufacturing intent. And so any materials illustrating the thought process behind manufacturing of custom parts would contribute to receiving that full score. So I think what we mean is that if you include any Onshape drawings, any manufacturing drawings, it's going to help us know when we're judging that you did consider how feasible it would be, because that is one of the categories on the rubric is feasibility. So we're just trying to look at whether or not you thought about feasibility with your drawings that you add. Nope, someone, not a question, but someone else said it's been fun working on this. I definitely hope that's an experience everyone working on this has had. We definitely hope this is a good chance to get to work with your team some more and have fun with designing.
And I know we've said this quite a few times in our emails, but I am beyond excited to see a really cool like library of robots that you all have put together. I think, just due to how Onshape works and the ability to just share a link and then all of a sudden I'm looking at your robot is really cool to just have all that information kind of in front of us and to be able to see it. So that will be super exciting. And I know you all will probably really enjoy seeing each other's robots. We're going to do this really cool award ceremony where we show people's designs and you can take it all in, and it'll be really fun. So.
And then also keep in mind, this is our first time doing this. We definitely would love feedback. So we sent out a feedback survey, so please be filling that out and letting us know if you have any feedback.
Yeah, and that feedback, to reiterate, is totally anonymous. It does not impact your score. We don't know what your name is or anything like that. So just keep that in mind.
And then going back to the drawings, those drawings aren't part of the 3 pages, right? It's just part of the Onshape package submission. So part of your Onshape document link that you'd be submitting. And that is correct. As long as your drawings aren't part of that 3-page PDF and they're just essentially another tab in your Onshape documents, that's totally fine. So it looks like that's all the questions we have. Thank you to everyone who joined us and asked us questions tonight. And definitely keep in mind, you can always be emailing first@ptc.com. Now and then, even once the competition is over, as you get ready for next season and you have questions about using Onshape and getting your team set up, we're definitely happy to answer anything you're wondering. Anything else, Dom or Mark, that you'd like to add?
Not really. Thank you for everybody for joining tonight, and we're really excited to start getting a bunch of these submissions in a couple days here.
Yeah, and I think the only thing too is just check your emails in case anything comes up from us. We'll let you know, but I think things are smooth. We've gotten some submissions already, so we're excited about that, and look forward to seeing a lot more. Don't wait until 11:59 on Friday. Do it a little bit earlier than that, just in case. So, all right. Thanks everybody. It's been great talking to you all tonight, and we'll be in touch with all of you for sure. Have a good one.